All right, everyone. Right now, we're going to complete the notes on ratios, proportions, and similarity. We left off with the practical problems or the problems relating to similarity statements, which is where we're going to pick up in this video. So our directions in this question say to list all congruent angles and to write a proportion that relates the corresponding sides. So we just need to make sure that we rely or refer, I should say, to our similarity statement right here to match up our corresponding parts. So for example, angle J is the corresponding angle to angle P. Angle K corresponds to angle M according to our similarity statement, and L corresponds to N. So now, based on our picture and the similarity statement, we can write congruency statements of all of our corresponding angles. So angle J is congruent to angle P. Angle K is congruent to angle M. And angle L is congruent to angle N. So this is exactly the same as what we've been doing in the last unit with congruent triangles, just matching up all of the congruent parts that correspond to one another. Sides are a little trickier because sides are not congruent, so we can't write congruency statements, but we're going to write proportions because in similar figures, the sides that correspond are proportional. So we're going to make three equivalent fractions where we compare each of our three corresponding sides. So we could call our first side JK, and we're going to make that a fraction with the side that corresponds to it, which would have to be, again, I'm just matching up my letters here, PM. So then our second side we could call KL, and that would correspond to our second side of our second triangle, which would be MN. Again, just keeping the order of your letters straight, that's really important. Our last side is the third side, JL, and that would correspond to the third side of our second triangle. Again, keeping the letters straight would be PN. So that's the difference, is instead of writing a congruency statement, we write a proportion comparing all of our pairs of matching sides. Let's try another one. So in this case, we're saying that angle X, triangle XYZ is similar to triangle RYS. Triangle RYS is laying on top of triangle XYZ. So of course, angle Y is congruent to itself. Angle X is congruent to angle R according to our congruency statement, and angle Z is congruent to angle S. So again, same type of thing. The angle should be pretty easy. That should be a review. The sides are a little harder, where we have to create a proportion where we compare our three corresponding sides. So our first side we could call XY. So we just need to make sure that we use the matching letters of our second triangle. That would be RY. Our second side could be YZ. And our second side would be YS. And then our third side, I'm going to call XZ. And then our third side would be RS. Notice that I keep the fractions consistent in terms of always putting, in this case, my bigger triangle on the top and my smaller triangle on the bottom. It doesn't matter which triangle goes where, as long as you keep it consistent throughout your entire proportion. Similarly, it doesn't matter what you name your sides. I could call this side YX, for example, but I would just need to name my corresponding side in the same way. Okay, last one. This is a quadrilateral, being similar to another quadrilateral. So again, we'll have, in this case, 4 corresponding angles and 4 corresponding sides, but we'll do the same thing. We'll just match up all of our pieces using our similarity statement. So angle J is congruent to angle Q. Angle K is congruent to angle R. Angle L is congruent to angle S, and angle M is congruent to angle P. Our sides are proportional, which means we need 4 fractions to match up each of our 4 corresponding sides. The first one we'll call JK, corresponds or is proportional to side QR. Always matching up. So I'm sticking with my first quadrilateral on top, KL, corresponds with RS. LM corresponds with SP, and JM corresponds with QP. So this is something that would be a very typical question that you might see on your quiz on Friday, for example. Okay, last type of problem that we're going to do today is finding side lengths using proportions. So we know that side lengths are not congruent in similar figures, but they are proportional. So we'll use proportions just like we did right here to solve for missing side lengths. So let's take a look at what that's going to be like. So they're telling us that we have a scale factor of 2 to 3. Remember, a scale factor or a similarity ratio, either term could be used, is another way of writing a fraction. So that's our first fraction. We know that all of the sides have to be in that same ratio. So since my 2 is on top, then I'm going to put my smaller side on top and its corresponding side of my bigger polygon on the bottom. And then we just solve this using proportions. So it's just like a problem previously. So we would get 2 times x is equal to 3 times 42, remember. So 3 times 42 is 126, and then divide by 2 on both sides to solve for your x, and you get 63. So that missing side length is 63. We solved it because sides of similar polygons are proportional, so we just use a proportion. In number 5, again, if the figures below are similar, this time they have a scale factor or similarity ratio of 6 to 5. This is the bigger one, and this is the smaller one. Find the value of x. So 6 over 5 could be our first fraction or our ratio. And then since my bigger number is on top, I put my bigger side and my bigger triangle on top over the corresponding side of my smaller triangle, and then cross multiply and solve. Okay, so to solve this, remember, we just need to multiply 6 times 28, and we get 168. 5 times x gives us 5x, and we'll solve for x by dividing by 5 on both sides, which gives us an answer of 33.6 in this case. So this missing side length right here is 33.6. 6 and 7 are slightly different. So in this case, they're telling us that these two triangles are similar, but giving us a similarity statement so that we can figure out which sides correspond to each other based on that similarity statement. So they don't give us a scale factor like they did in 4 and 5. What they do is they just give us 2 pairs of corresponding sides. So we'll use those 2 corresponding sides to create our proportion. So AB corresponds to DE. So AB is right here, so that's X, and it corresponds to DE, which is 25. And then BC is right here, that's going to correspond to EF. So BC is 28 over EF, which is 20. Make sure that you keep your numbers from the same triangle in like the same area of the fraction. So now we can cross multiply. 20x is equal to 25 times 28, which is 700. And then when we divide by 20 on both sides, we get x is equal to 35. So number 7 is just the same, except we're given quadrilaterals, but we still have a similarity statement, which allows us to match up our missing sides or our corresponding sides. So side PS would correspond to side WZ. So my first fraction is going to be 75 over 40. And then my second fraction involves RS, which are these two sides pieces right here, corresponds to YZ, so X over 32 to complete my proportion. Cross multiply and we get 40x is equal to 75 times 32, the big number, 2400, is that right? And then we just divide by 40 on both sides, which gives us an answer of 60. It's never a bad idea to also just go back and take a look and see if that answer makes sense. So for x to be 60, it should be smaller than 75 because 32 is smaller than 40. And it should be bigger than 32 because this is the bigger quadrilateral. So it should be bigger than its corresponding side in the smaller quadrilateral. So that seems like an answer that's within the realm of being reasonable. Okay, so we're going to do a few more together. Then I'm going to let you go and try some on your own. Okay, so the difference in 8 and 9 is that now we're being asked to find two variables, but again, we still just set up a proportion with matching sides. Use your similarity statement whenever you're given one to find your corresponding sides. So side X, which is side GH, so I know I need to use that one, is going to match up with FD. So I can say X over 12, for example. And now I need a pair of sides that matches. So I don't want to use side Y. I want to use side HJ because that is going to be a complete proportion. I can't solve something with two variables. So HJ corresponds to DE, which is 9. Okay, so now again, just cross multiply and solve. So I get X is equal to 20. I'll do the same thing to find Y. Y corresponds with 14. And I'll use that same 15 over 9 to solve for it. So 15 times 14 gives me 720. Sorry, 210. I don't know what I'm looking at. Divide by 9 on both sides, and we get y is equal to 23.3. Okay. In number 9, again, we're given a similarity statement. We're asked to find x and y. So side x is KL. So in the second triangle, the corresponding side would be ML, which is 14. And then we need a complete ratio. So if I use KJ, that's MN. That would be 40 over 16. And now I just cross multiply and solve. I get x is equal to 35. And then now I can create a proportion using my y. So what I'm going to do is match up my y. Y is side LN, which matches up with side LJ. So I'm putting LJ on top just because that's the way I did that first one. So it should be 45 over y is equal to, and then I can use that same 40 over 16 proportion. It doesn't really matter. You can write your proportions in a lot of ways that are correct. You just want to make sure you're always being consistent. That's the biggest key. So we get 40y is equal to 720. That's where the 720 came from that I was thinking before. And y is equal to 18. Okay, so there are more practice problems that get a little bit more challenging. You will not be required to do any of those for the quiz. So we're not going to spend time going over them in the video. However, if you want to see me during office hours, we can totally go over them. but the ones you will need to know how to do for the quiz are up through number 9. If you have any questions, come see me.